Hello students, let's continue once again the last concept, that is we were discussing about the thermodynamic process and its types. Process is an operation by which the system changes from one state to another state is called a process. The process is divided into 5 types. The first type we have already discussed, isothermal process, the process in which the temperature of the system remains constant, unchanged during the process is called isothermal process. Another is adiabatic process, the process in which heat energy of the system remains unchanged throughout the process is called adiabatic process. That is delta Q is equal to 0. In isothermal process, delta T was equal to 0. Let's proceed further. The third type is isobaric process, where bar stands for pressure. Okay, here look at the system. Here there is a gas which is being heated by this ventile, and this is a piston which kept the pressure of the gas constant. Okay, the process in which the pressure of the system, obviously the system pressure is the characteristic property of gases, that is why the system must be in the gaseous state. The process in which the system's pressure remains unchanged during the process is called as isobaric process. Here if you look at, on the x-axis volume is taken, on the y-axis pressure is taken. Okay, then during the process, during the heating of this gas, means we are changing the state of system, we are carrying out the process. During this process, if the pressure of the gas enclosed in this cylinder, which is fitted with the weighted piston, which is having a certain weight which does not allow the pressure of the gas to be changed. Okay, that is why it is called as an isobaric process. In a brief, once again I will repeat, the process in which the pressure of the gas is remained unchanged, okay, is called isobaric process. Here delta P is equal to 0, since P1 is equal to P2. P1 is the pressure of the gas, the pressure of the system in initial state, and P2 is the pressure of the system in its final state. And if the value of both P1 and P2 is same, that means pressure remains unchanged. The fourth type is isochoric process. Isochoric process. Core means volume, C-H-O-R-E, core means volume, and iso stands for constant or unchanged. Now you can define by yourself this system. The process in which volume remains constant is known as isochoric process. The heating of the substance in the non-expanding chamber. Non-expanding means the chamber which does not allow the gas to expand. Expand means the increase in volume. Okay, if we heat any gas, then its volume increases, but here we are carrying out this process in such a chamber which does not allow the gas to change its volume. In such a chamber, if we are carrying out the reaction and by heating the gas, then the volume does not changes during the process, throughout the process. That is why this process is called isochoric process. Means here volume remains constant. Volume remains constant. That because of this chamber which does not allow the gas to expand, gas to increase the volume of that system. Okay, that is why it is called as isochoric process. And in an isochoric process, always delta V is equal to 0, since V1 is equal to V2. That is why the difference between them also equal to 0. The next type is a cyclic process, a kind of different definition we can observe here. The name itself, cyclic process, means it completes one cycle. The process go through different steps and come back to its original state. Means during the process, system changes from one state to another state and proceeds through a number of steps and come back to its original state. Here, system from this state A convert into B and again come back to A. The whole one cycle completes here. That is why this system, such systems are said to be cyclic process. Let us try to read the definition. When a system in a given state goes through a number of different processes and finally returns to its initial state, the overall process is called cyclic process. Means the system is in a particular state which converts into another state, go through the number of steps and processes and come back to its original state, that is initial state. That is why such systems, that is why it completes a one whole cycle. That is why it is said to be a cyclic process. And during this, for any cyclic process, always delta E is equal to 0 and delta H is equal to 0, where delta E stands for the difference in internal energy of the system and delta H is the heat energy of the system or enthalpy of the system. But for now we can consider it as only heat energy. Okay, heat energy delta H, H2 minus H1 or Q2 minus Q1 is always equal to 0 for a cyclic process. The another concept in this chapter is the reversible process and irreversible process. What are reversible process and what are irreversible processes? Now as we know that student, there is always certain force which makes the reaction to occur, and there is another kind of force which opposes the reaction to occur. Okay, means the force which causes the reaction, which pushes the reaction to occur, such forces are called driving forces, and the force which opposes the reaction to take place to occur, such forces are called opposing forces. Okay, if we talk about the reversible process, okay, first of all, this is the reversible process. A reversible process is a process that can be reversed in order to obtain the initial state of the system. Means simply by the name of that process itself, it says that the process which can be reversed to get back the initial state of the system, such processes are called reversible process. And the process which cannot be reversed so as to obtain the initial state of the system, such processes are called irreversible process. Okay, let us try to understand the reversible and irreversible process in a simple way. Okay, suppose there are two students of equal strengths and they are asked to push each other into the opposite sides. Okay, what will happen? Remember, both the students are having same strength or a little bit difference in their strength. Then sometimes A student will push the B students back, or sometimes B students will push the A student back. Okay, means in this way they go to the completion. But in case of, if there are two students, one is very weak and one is very strong, and if we ask them to push each other in the opposite direction, then what will happen? The boy which is having greater strength will push the weak students to the opposite side in a one way. Okay, there is no chance of getting back the more strengthened student by the weaker students. In simple way, now by taking these two examples, we can say that reversible process is a process which can be reversed by having the very infinitesimally small difference in driving force and opposing force. Okay, suppose there is one process in which every process has the two forces. One is driving force, which causes the reaction to occur, and the opposing force, which doesn't allow the reaction to occur. Okay, if the difference between these two forces is very small, then sometimes the reaction will proceed in forward direction, sometimes the reaction will proceed in backward direction. Okay, let us try to understand now. When the driving force is infinitesimally greater than the opposing force, then the reaction will proceed in forward direction. On the other hand, when the driving force is infinitesimally greater than the driving force, then the reaction will proceed in backward direction. In this way, the reversible process proceeds in forward as well as in backward direction. But in case of irreversible process, that cannot be reversed, means that takes place only in one direction. But in case of reversible process, that takes place in both direction, forward direction as well as in backward direction. And irreversible process proceeds only in forward direction but not in backward direction. Okay, I hope you have understood what is mean by reversible process and irreversible process. Here are the few things are applied to this reversible and irreversible process. Reversible process can be reversed. Irreversible process cannot be reversed. That part we have already discussed. Infinite changes occur in the system. Finite changes occur in the system. Means the changes occurring in the reversible process are infinite. The changes occur to the larger extent. But in case of irreversible process, the changes occur to the very limited portion. Okay, means finite changes occur in the irreversible process. Okay, during the irreversible process, there is an equilibrium between the initial state and final state of the system. When the reversible process proceeds, okay, reactants are converting into products as well as the products are getting converted into reactants. This is a reversible process. But in the reversible process, the equilibrium state is attained during the reversible process. I think already I have discussed what is the equilibrium state in the very first class, though I will repeat it again. The equilibrium state means the state at which the concentration of reactant and concentration of product become equal, or the rate of forward reaction and rate of backward reaction becomes equal. That state is called equilibrium position. Or to understand the equilibrium state concept simply, let us have on the roof of your home, if there are two water tanks of same quantity capacity, okay, but one is fully filled with water, another is empty, and if the two tanks are connected through a pipe with the knob, then what happens? If we switch on the knob, slowly and steadily the water in the first tank, who is fully filled, get transferred to the another tank slowly and steadily. But there's after some time the stage will come, the flow of water stops. Stops means maybe the number of molecules get exchanged, but the quantity, the flow in quantity gets stopped. Means that state is called as equilibrium state, where the quantity of water in both the tanks is